That's a really good question, and as everybody knows, hydrogen fueling, hydrogen energy has been around a long time. Utilizing it in the way that kind of revolutionizes the way we do things has been some challenges, but it's not unusual to going from CNG to hydrogen. They're very similar fueling experiences. So we've because fueling needs to be safe. The customer needs to feel safe, and we obviously need to comply with regulatory climates that ensure that local regulators as well as national and federal regulators approve the fueling process for use by consumers. We're the only frame-to-finish fuel dispenser that currently has all the regulatory requirements necessary. That's Met Labs, CSA, local NFP fire approval, through the way that we actually purge the system to ensure that there's no potential spark or electricity that could ignite, and in fact utilizing systems within the dispenser to contain the pressures that are used in hydrogen. For those who don't know, hydrogen pressures can actually exceed 15,000 psi in some cases. So containing those in a way that the consumer and people at the station would never be exposed is a high priority.
Yeah, and one thing that we'll have the advanced driver feature segment here in a little bit, but one of the really cool things about the Nikola truck is how advanced it is we'll have, the son we're going to be working with the station dispensers on is the fact that we have RFID chips built right in. So an owner-operator pulls up to one of our stations, he doesn't need to worry about swiping a card going inside. He pulls up and literally just connects in, and it pulls up, it produces a virtual invoice right there of $0, which is a great feeling, and it lets you know exactly how many kilograms you put in your truck. And that's all done virtually, it's all done through an RFID. You don't even have to worry about it, you just pull up, you get unlimited hydrogen, and it doesn't matter how many miles you guys drive. And you don't have to worry about the handshake, you don't need to worry about going inside, you don't need to worry about swiping the card. You just do it. And that's a really cool thing. So we'll be working with Bennett. It's a lot of technology that has to be integrated. It's going to take a few years to really get those handshakes perfected. But RFID technology has been around, so it's not something necessarily new. It's just new to what we're doing. But my goal is to simplify a driver's life. That's everything I live on. I mean, I get in trouble when people say, you know, Trevor, don't talk about too many things. But I envision a day where when a driver's going, essentially his guy next to him can pull up on that 21-inch monitor and pick what he wants from our truck stop before he gets there and is waiting for him. The driver doesn't want to be standing in line, doesn't want to be dealing with stuff. He doesn't, you know, his time is valuable. He's already driving. He wants to spend time with his family, his pets, or whatever else he has. And I'm just a big believer in solving every awful product that's out there in the world. I can't live and just be okay with something that's mediocre. So I'm going to continually push ourselves and my company to make sure that we're more advanced than anybody else. And we can move, I can promise you this, by the time these other OEMs come out of their meetings, will come out with a new truck. That's essentially the rate of speed that we can move. It would take someone in committee 2 or 3 years to come up with a truck. We built it. Yeah, go ahead. That would work.
My question is, what pressures are we going to be running on this truck? And then also, fuel tax, is that going to be at the pump?
Yeah, good questions about fuel taxes and pressure on the truck. So this truck right now is slated at 5,000 psi. So there's different levels you can go to. You can do a 5,000 or kind of like around a 10,000. They're working on higher standards. The problem with hydrogen is well, the advantage of hydrogen is you can it's a very you can keep on compressing it and putting more in. Unlike natural gas, where as soon as you get up to about 4,000 psi, the advantage of compressing it doesn't help much more anymore. But because the truck has so much room, the cost of the tanks is very expensive. So it's nearly 3 to 4 times the cost for a 10,000 psi tank than it is a 5,000. So it's one reason why the cabinet's a little bit bigger. Cuts down on the cost, but we can still fit 100 kilograms. In the future, if we ever wanted to go, we ever wanted to get to a position where the pricing starts to fall, we could shrink that cab in half, put it up to 10,000 psi, and you would still get the same range. Taxes are going to be, we're working those out right now, but as of right now, they should be prepaid into that lease for the road taxes. So we're going to prepay it, and then we'll pay the states based upon the miles that they're driven in their state. So it's a very confusing thing that we're working on, but that's our goal. Yeah?
My name is Sophia, and I'm in 7th grade, and I was just wondering about how so many companies like Mercedes, for example, have tried to work with hydrogen engines, but they have failed because it's incredibly difficult to work with. What made you succeed, and how do you make it safe? Like, for example, if you were to get into a car crash, then how wouldn't the tank explode, etc.?
You're way too smart for your age. Then I'll get into the story.
That is actually a great question, because we work directly with the manufacturers on these cars that are actually being delivered today in the United States. We're working with Mercedes. Their new SUV has been delivered in California. Toyota's just delivered the Mirai to California in the Northeast. And Honda, as well as Hyundai, both have 2 new vehicles coming out that are 100% hydrogen powered. Your question is accurate. Over the years, we've had a lot of difficulty figuring out how to make the vehicle safe, while at the same time getting the energy to get the vehicle as far as we need it to go on a tank of gasoline, not to mention the infrastructure needed to go from station to station. You now can, in California, go from San Diego all the way to Lake Tahoe and fuel all the way, because there's stations all the way. So it's a pretty cool technology that's got a lot of advancements. But the advancements as far as the safety, and that's the part you asked the question about, is that the way they make the tanks now and the way that they encase them provides actually more safety than what we've seen with traditional fuels. If we were to come out with a traditional fuels car for gasoline today, it would be very different. In fact, likely wouldn't pass any regulatory climate. Everything's been grandfathered in for so long because it's what we've had for over 100 years.
Yeah, and a lot of advancements in the new fuel cell technology has come over the last few years. So there's been a lot of issues with fuel, with getting them. One of the main reasons is that in a car, you don't have much space. They're very compact. On a truck, you have a whole lot more space. You have more space to work with. You have better cooling techniques. You can make thicker membranes. One of the things inside fuel cells are they call them stacks, and those membranes are very thin. And so in our truck, they're much thicker, and that allows us to get more longevity out of it. Unfortunately, in a car, there's almost no room. These guys are. You look at the gap between, say, the hood and some of your features on your car. Sometimes it's just a few millimeters. So they just don't have any room to give. And that's really the reason why a lot of the fuel cell technologies failed, is because there's not enough room to make it work. With our truck, we have a lot more room. There's just, look how big this is compared to a car. So it's a natural involved. For me, I believe trucking is really where the fuel cell technology is going to go from. You asked about a wreck. If this thing were to get into a wreck, first of all, the tanks themselves are, some of the requirements they require is it's called a bonfire test. You'll actually put the tank next to a bonfire, and you'll shoot it with a 30-06 gun. And it actually won't even penetrate the tank. So the safest place on that truck is really inside that tank. Most people don't realize it, but it is. If you were to have a catastrophic failure and an impact, if there was a certain amount of pressure and heat, it would purge up. And hydrogen's, I think, 22 times lighter than air. So it would dissipate the air very quickly. And you'll actually notice at the top, there's little holes shooting out. We have high pressure lines and purge valves. This is the company I came from. This is what my previous company. It purges all up into the atmosphere immediately. So it would keep the driver safe. But I hope that answers your question. I will take one or two more, and then more. Yeah.
Mike, go ahead.
Or Mike, go ahead first, and then him.
Hi, Trevor. Are your stations going to be able to fuel my Toyota Mirai?
Yes, it will. Yeah, we're going to open it up to everybody. Our goal is to have it somewhere around $3.50 a kilogram. Could be somewhere in that area. That's equivalent to about a little over $1.50 in gasoline per gallon. So that's our goal is to be able to offer it to not just our trucks, but then have islands for the regular cars as well. Oh, go ahead.
Just real quick, got a couple of questions, if I may. Rick Hogan, I'm an independent solar from Chicago. What was the reason for the switch from natural gas to hydrogen?
Okay, that's a question we got a lot on social media and a lot of other questions with the press. There's a couple of main reasons why we went to hydrogen. The big overlaying ones is the most important, is hydrogen has zero emissions. That's a really important one, because then we're not going after an archaic technology where you're always having to recertify and make it more and more, with less and less emissions, as you've seen with these vehicles. So number one is zero emissions. Number two is the fact that a turbine is noisy. There's noise to it. So owner-operators don't want to be woken up at 3:30 in the morning if all of a sudden their battery levels get too low and the turbine kicks on. We can sound dampen that. We got these air systems, you can still hear them. They've been able to sound dampen them. But once again, that's almost like throwing a Band-Aid on something, right? A fuel cell is almost silent. The only thing you have is an air blower. So it's very, very, very quiet. So you have zero emissions, silent, and we all know that the world is going to zero emissions. So we better just get on board. Why go after something that's not? Why take one step back when you can take 2 steps forward? And the last reason is the certification and time to market. It's actually going to save us a couple of years by going to the fuel cell because the emission certification is almost non-existent. You have a little bit. You got to go in and in your applications, you're going to go through and check out what engine you have, and you'll say hydrogen, okay, fuel cell, what kind? It's a PEM fuel cell, and then they run you have a couple tests, and really, they already know through physics and through all this data that they don't produce emissions. So the time to market it'll save us probably more than $100 million. That's another reason, and I'd like to keep my money. All right, one more, and then we'll move on to the
Two-part question. What kind of temperature can you handle on the low end, negative temperature, and how far north are you guys planning to have refueling stations? Like into Canada, maybe even higher, Alaska?
You can go on our site to see that the list of all the stations. They went live last night around pretty late after the show. There's essentially 364 stations planned across the U.S. and Canada. The great thing about hydrogen at school is you can't freeze it. I think it's negative 456 degrees to liquefy it. And so, not bad for a guy who didn't go to college, right? It's negative 456 degrees to liquefy, so you won't have any issue with any, oil, actually diesel will actually gel up. You don't have to worry about it with hydrogen. It's really rad. Got a little bit of, the batteries will actually warm up before you can, if it gets really cold. The batteries will warm up, and our system does that automatically to make sure they're within temperature where it doesn't affect them. But that's all done kind of automatically, and our goal is to, through your mobile apps, to be able to actually tell your truck how far out you are, and it can pre-warm it so you're ready to go when you want to go. Just warm up the batteries. But we'll have the stations all the way up there. Hydrogen doesn't really have an effect on what about fueling? Do you have any issues on your end with fueling up in the super cold areas on your stations?
Up to 40 below with all the systems, no problem.
All right, guys. Bennett's a great company. They've been really gracious to bring up one of their dispensers here, and you guys can talk to them about how they dispense. And you'll actually, on the truck, you'll see on this back door, there's a little black door. There's 3 nozzles there. These nozzles are essentially standard. They're very similar for both CNG and hydrogen. So you guys will be able to look at it and see it's the exact same process as filling up with natural gas is filling up with hydrogen. So you guys will be able to mingle and ask all the questions you want to Bennett, and we'll for sure be working with them on a ton of equipment moving forward. Thanks, guys. All right, the next one is the powertrain. Is Kevin here? So Kevin's our lead engineer. You guys saw him last night. Give him a little round and give him a round of applause.